Hello, my name is Evan Acosta. This is my Lab 1 video report on the observation of an object in constant motion. So the goal of the lab was to track the motion of an object with constant velocity and then create both a computational model in GlowScript and a model to observe it in the real world in Tracker. And then we are going to compare it to each other, see how they differ in the computational model versus the real world, and relate it to what we've been learning in physics so far. So I have these two equations which kind of form the backbone of the lab. F net equals ma, which can be broken down into, uh, you know, momentum, the kinematic equation, and all of that. And then velocity, which is the rate of position over time, and the position update formula, which we have been using a lot lately. I will explain these more in depth and relate them to the lab as I go forward. So I'm also going to show you some of the experiment and the code screenshots. So this is a screenshot of me in Tracker tracking the position of the marker. I have an axis which is basically just tracking the marker. And then on the right side, it's the loop that will calculate the velocity over and over again of the marker, and then plot it on a graph to show its velocity and its position in time, as well as create a 3D model of it. So here's the 3D model and the graphs as shown before for the GlowScript model. Um, I used the tracker results to determine how far the marker rolled, which was 0.323 meters in roughly half a second or 0.43 seconds, and then use that to find a average velocity that I plugged into the computational model, which gave me this velocity right here, and this position and position change. So already this is using some of the equations and formulas that we've learned in class. Um, the comparison between the observed and predicted motion, the predicted motion was constant. Obviously, I didn't have any net forces acting on it in the opposite direction, but according to the tracker data, it was not completely constant as it was in the computational model in the real world. And we're just going to go over why that may be. So why did they differ? How else could these results change? So the observed motion in the real world was different to the predicted motion because there's a lot of additional forces in the real world that the program wouldn't take into account. Things like friction, um, the axes maybe being misaligned in tracker, the calibration maybe being off, the marker possibly not rolling straight. There's a lot of different ways that the results could change. Um, so what does this all mean? The computational model is relatively accurate, but it does leave out a large amount of variables that affect the motion of objects in the real world. Other forces like friction, air resistance, and the whether or not the table is even level could affect this motion. But the computational model is really quite helpful in determining like some base level of behavior that these objects have. For instance, you could use the computational model to determine like what kind of net forces are being applied at the marker. For instance, here, since you know that the velocity is less than the the velocity for the observed in the real world seems to be less than the velocity in the constant not constant for the computational model. You can tell that there must be some kind of net force, and you could kind of imply that that might be the friction or something like that. So this lab kind of put together everything that we've been working over the past week or so in physics, kind of making us think about the motion of an object in the real world, how net forces might affect that constant motion, and being able to use formulas like the kinematics formula to describe the motion of an object, to create a computational model as well as really be able to describe the motion of an object in the real world versus just, you know, filling it out on a test and seeing it on paper. So that's it for my lab report. If you guys want to look at this, here is the rest of my code for the model, and that should be it. Have a great one, guys.